Our last section for this chapter is polygons in the coordinate plane, so polygons on a graph. So with that, we're going to have to use our formulas, so distance formula, midpoint, and slope. The hard part about this is deciding when to use each formula. So when the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so you're going to use that if you're trying to determine that sides are congruent or diagonals are congruent, because you want to show that those things have the same length, which would mean that they are congruent. The next thing is the midpoint, which is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And remember, you write that as a point, and you're going to use that if you're trying to determine if coordinates of a midpoint of a side or if diagonals bisect each other. Because remember, if they bisect each other, that point will be right in the middle, which was where you would use the midpoint formula from. And then you have the slope formula, which is y2 minus y1 divided by x2 minus x1. And so that you're going to use to determine whether opposite sides are parallel, diagonals are perpendicular, or sides are perpendicular. So remember, if they have the same slope, they're parallel. If they have the opposite reciprocal slope, then they would be perpendicular. So that what you would use if you're trying to show that something has a right angle. So our first example problem is classifying a triangle if you're given the vertices A is 0, 1, B is 4, 4, and C is 7, 0. So in order to figure out a triangle, we're trying to figure out if it's scalene, isosceles, or equilateral. And we'll figure that out by looking at the distance. So we got to figure out how long is AB, BC, and AC. So I'm first going to just start with AB. I'm not going to rewrite the distance formula just because it was on the last page. So I'm going to plug in. I'm going to do x minus x, so 4 minus 0 squared plus 4 minus 1 squared. And I'm going to simplify from there. So I get 4 squared plus 3 squared. And remember, when you're squaring, you're multiplying something by itself. So 4 times 4 gives me 16, and then 3 times 3 gives me 9. And we keep it in the square root unless we can take the square root of it. And actually, we can take the square root of 25. That gives us 5. So that means that side AB is 5. Next, I'm going to do the same thing except for side BC. So now I'm going to be using these 2 points. So I'm going to do my x minus x, so 7 minus 4 squared plus 0 minus 4 squared, and simplify. So 7 minus 4 is 3 squared plus negative 4 squared. So 3 times 3 gives me 9, and negative 4 times negative 4 gives me 16. And again, that gives me the square root of 25, which is 5. So BC is also 5. So right now I have an isosceles triangle. So what I have to do is figure out AC to see if it's going to be equilateral. So I'm going to plug in 7 minus 0 squared plus 0 minus 1 squared and simplify. So I get 7 squared plus negative 1 squared, and 7 times 7 is 49, and negative 1 times negative 1 is 1. So if I simplify this, I get the square root of 50, and I cannot break that down to be a whole number, so I'm just going to leave it as the square root of 50. But I do know that that is not the same as the square root of 5. So that means that I have 2 congruent sides. So that would make this an isosceles triangle. The next thing I'm going to do is I'm going to decide if ABCD is a parallelogram. So in order to do that, I have to think back to all my rules about a parallelogram. It's going to be too hard to show angles are congruent. That can't really do that when you have a coordinate plane. So we're going to have to do something with the sides. So to save ourselves some work, what I'm going to do is we have that one theorem where if we show that the sides are congruent and parallel, those same sides, then it's a parallelogram. So I'm going to do both of those things. So I'm going to do AB, I'm going to first show that they're congruent, meaning that they have the same length, which if I'm trying to show they're congruent, I'm going to be using the distance formula. So I'm going to do AB, so I will do 4 minus 0 squared plus 0 minus negative 2 squared. And so that gives me 4 squared plus 2 squared. And 4 times 4 is 16 plus 4, and that gives me the square root of 20. So then I'm going to do, and leave it in the square root because I can't simplify, so this side is square root of 20. I want to do the same thing with CD, so I'm going to do 5 minus 1 squared plus 4 minus 2 squared. And simplifying, that gives me 4 squared plus 2 squared, which is 16 plus 4. And so I do get the same thing. I get square root of 20 again. So I have shown that the sides are congruent. Now I need to show that they're parallel. So if I'm showing that something's parallel, I'm going to need to use the slope. So I want to do the slope for AB, and then I want to do the slope for CD. So I'm going to do y minus y over x minus x. So I will do 4 minus 0 over 0 minus negative 2, which gives me 4 over 2, which simplifies to 2. And then CD, I'm going to do the same thing, y minus y over x minus x. So I'm going to do 5 minus 1 over 4 minus 2, which gives me 4 over 2, which is 2. So they are parallel as well. So since I have proved that, that means that yes, it's a parallelogram. And I use 2 lines to say parallel. And our last example is EF the mid-segment of the trapezoid? So in order for the EF to be the mid-segment, remember the mid-segment is the middle of these two sides here, these two legs. So E would have to be the midpoint of AB, and CD would have to have the midpoint of F. So I have to use my midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So I'm going to look at AB. I'm going to do 6 plus 4 divided by 2. And that gives me 10 divided by 2, which is 5. And then I'm going to do 8 plus 2 divided by 2, which gives me 10 divided by 2. And that is 5. So my point for EF, if this was on a graph, would be 5, 5. And that's what they said it was. So yes, E is the midpoint of AB. Now, for it to be the mid-segment, though, F also has to be the midpoint of CD. So I'm going to do the midpoint formula again for CD. So I'm going to do 5 minus 1 divided by 2, which is 4 divided by 2, and that gives me 2. And then I'm going to do negative 10 minus 6 divided by 2, which gives me negative 16 divided by 2, which is negative 8. So I get the point 2, negative 8. Again, if this was on a graph, this would look better. And that is what they said F would be. So yes, it is the mid-segment because E and F are both the midpoints of the two sides.